Good evening, dear students. My name is Ferhan Mazher, and in this video, we are working on the exercise 9C, and this is our third episode on this exercise. And in this video, we will start work from the question number 3. The exercise 9C is about the integration of the expression of the forms of the ax plus b whole raised to power n. This is the course book of the pure maths 1. This is paper 1 of the Cambridge International AS A levels mathematics 9709. So let me show you the question number 3 on your screen. So this is exercise 9C basically, and I'm working on the question number 3. A curve is such that dy by dx is equals to k bracket x minus 5 bracket close whole raised to power 3, where k is a constant. The gradient of the normal to the curve at the point 4 comma 2 is 1 by 12. Find the equation of the curve. So this is the question number 3 of the exercise 9C. So let me show you how this is done. So it is given that dy by dx is equals to k x minus 5 whole raised to power 3, where the gradient of the normal is 1 by 12 at the point 4 comma 2. If the gradient of the normal is 1 by 12, the gradient of the tangent at that point will be reciprocal of this gradient, and the sign should be changed. So the gradient of the tangent will be minus 12, because the normal and the tangent, they are perpendicular to each other. Now, the dy by dx, that gives you the gradient of the tangent at the point x equals to 4. So in this expression of the dy by dx, where you have the x, substitute that x with the 4. So you will have dy by dx equals to k bracket, in the place of x we have put 4. So it's 4 minus 5 whole raised to power 3 equals to the gradient of the tangent, which is minus 12. So from here, k bracket minus 1 minus 1 raised to power 3 equals to minus 12. So it's minus k equals to minus 12. So minus minus will be cancelled. So k will be equals to 12. Now I know the value of the k. Put the value of the k here, and then integrate both the sides. So you can see here, we have put the value of the k 12. Then we integrated both the sides. So this will become y. This will become 12 into x minus 5. And the power is increased by 1 in the integration. So it will become 3 plus 1, that is 4. So with the same number, you have to divide plus c. Because this point is on the curve 4 comma 2, so in the place of the y, I will substitute 2, and in the place of the x, I will substitute 4, and I will try to find out the value of the c. So you will have 2 equals to 3 bracket 4 minus 5 bracket raised to power 4 plus c. So 2 into 3, this is minus 1. Minus 1 raised to power 4 is positive 1. So it's 3. So this 3 will go to the other side. So it will become 2 minus 3. So the c value will be minus 1. Now the equation of the curve, which is this, I now know the value of the c. The equation of the curve will become y is equals to 3 bracket x minus 5 bracket close whole raised to power 4 minus 1. So this is how you will do the question number, the question number 3. And let me show you the answers. Question number, we are working on the exercise 9C. Question number 3 we have attempted. Question exercise 9C we are working on, and the question number 3, its answer and our answer is same. So I hope you understand this. This is exercise 9C from the course book of the pure maths 1. My name is Ferhan Mazher, and this is our third episode on this exercise. I hope that this question is clear to you. So my dear students, exercise 9C, it's question number 4. This is our third episode on this exercise. He says a curve is such that the dy by dx is equals to 5 divided by under root 2x minus 3. Given that the curve passes through the point P, which is 2 comma 1, find the equation of the normal to the curve at the point P. This is the A part, and in the B part, the equation of the curve we have to find out. Okay, so this is question number 4. So I have already solved this on the board to save the time. So there are two parts of this question. In the A part, they ask us to find the equation of the normal at the point P. The dy by dx is given, that is 5 by 2 under root 2x minus 3. So this is an expression of the derivative. So this gives you the tangent of the, it gives you the gradient of the tangent. So the coefficient of the normal at the point P. So at x equals to 2, the dy by dx, put x equals to 2 here. So 5 by under root 2 into 2 minus 3. So that's 5 by under root 4 minus 3, which is 1. Under root 1 is also 1. So 5 divided by 1, that's 5. This is the gradient of the tangent. But we are looking for the gradient of the normal. The gradient of the normal at that point will be, you take the gradient of the tangent, you reciprocate it, you change its sign. So the gradient of the normal will be minus 1 by 5. Now, if you want to find out the coefficient of the normal who has this gradient and is at the point P, so I will apply this formula y minus y1 equals to m bracket x minus x1 to find the coefficient of the normal, which is a straight line. I will use this gradient and this point P. So y minus y1 equals to m bracket x minus x1, y minus 1 equals to minus 1 by 5x minus 2. Okay, so this will become y equals to minus x by 5 plus 2 by 5. This minus will come here, it will become plus 1. So now you will have y equals to minus x by 5 plus 7 by 5. Multiply everybody with 5 and you will have 5y equals to minus x plus 7. So this is the coefficient of the normal at the point P. Then in the B part, they ask us to find out the coefficient of the curve. So I will integrate this, okay. I will bring this under root upstairs. So its power, normally the power of this under root is 1 by 2. When you will bring it upstairs, the power will become minus 1 by 2. So dy by dx equals to under root 5 bracket 2x minus 3 bracket raised to power minus 1 by 2 d of x. This side will become y. This 5 will remain as it is. Its power will be increased by 1. So minus 1 by 2 plus 1. And that is 1 by 2. So you divide with 1 by 2. And you also divide with the coefficient of the x here. So this 2 and 2 will be cancelled. So you are left with the 5 bracket 2x minus 3 raised to power 1 by 2 plus c. I want to find out the value of this c because this p point is 2 comma 1 is on that curve. So here in the coin of the curve, wherever you have x, substitute it with the 2, and where you have y, substitute it with the 1. So 1 is equals to 5 bracket 2 into 2 minus 3 bracket close raised to power 1 by 2 plus c. This is 4 minus 3, that's 1. 1 raised to power 1 by 2 will be 1. That's into 5 will be 5. 5 will go on the other side, it will subtract. So you will have 1 minus 5 equals to c. So c will be equals to minus 4. So the coin of the curve, and the c value is minus 4. So 5 bracket 2x minus 3 bracket close raised to power 1 by 2. And in the value in the c is minus 4. Okay. So raised to power 1 by 2 means the square root. Okay. So y is equal to 5, the square root of the 2x minus 3 and minus 4. So this is the coefficient of the curve. And let me show you the question, the answer. Exercise 9C. And we have done the question number 4. And you can see it's A part, the coefficient of the normal is x plus 5y equals to 7. And the B part is y is equals to 5 under root 2x minus 3 minus 4. Our both answers are correct. So I hope you understand this question number 4. And this is our third episode on the exercise 9C. The topic of this exercise is integration of expressions of the form ax plus b raised to power n. This is the course book of the Pure Maths 1. The topic of this chapter is integration. We are solving AS Mathematics 9709. My name is Ferhan Mazher. So my dear students, exercise 9C, now we are going to work on the question number 5. He says a curve is such that dy by dx equals to 12 divided by under root 3x plus 1 minus 4x minus 2. Show that the curve has a stationary point when x equals to 1 and determine its nature. B part is given the curve passes through the point 0, 13. Find the coefficient of the curve. So this is question number 5 of the exercise 9C. This is our third episode on this exercise. And the topic of this chapter is integration. So let me explain to you. Okay. So the A part where we have to prove that the stationary point is at x equals to 1. At x equals to 1, there is a stationary point. Okay. So the dy by dx is given, and so this can be written as 12 into 3x plus 1 raised to power minus, bring it upstairs. So its power will become minus 1 by 2. The rest of the thing is same. Okay. So then when x equals to 1, in this expression of the dy by dx in the x, wherever you have the x substituted with the 1, so 12 divided by under root 3 into 1 plus 1 minus 4 into 1 minus 2. So that will become 12 divided by the under root 4 minus 2. So that is 2, 12 divided by 2 is 6, 6 minus 4 minus 2, and that's 0. So because, if on an x value, the dy by dx is 0, that means on that x value, we have the stationary point. Wherever you have the stationary point, the dy by dx will be 0. Now we want to find out the nature of that stationary point. We want to decide whether this is a maximum point or a minimum point. So we will have to take the second derivative. So this is my first derivative. So I will take its second derivative. So 12, this power will come on the side. The power will be decreased by 1. So 3x plus 1 raised to power minus 3 by 2. And its derivative will be 3. Minus 4x, its derivative will be minus 4. Minus 2, its derivative will be 0. So d square y by dx square will be equals to minus 18 divided by 3x plus 1 raised to power 3 by 2 minus 4. Now, in this expression of the second derivative, wherever the x is, put x equals to 1. So when I substitute 1, my expression is minus 18 by 8 minus 4. This answer is negative because the second derivative answer at x equals to the value of the second derivative when the x is equals to 1 is a negative number. So that means it's a maximum point. So that means that at x equals to 1, there will be a maximum point because the second derivative's value on that value of the x is negative. Now, in the B part, they ask us to find out the equation of the curve when the curve passes through a point. I just named it P is 0, 13. So we have to find out the equation of the curve. The first derivative is given. I will integrate its both sides. So integrate dy by dx. So 12 into 3x plus 1 raised to power minus 1 by 2 minus 4x minus 2. So integrate both the sides. So this side will become y. And when you integrate this thing, 12, this power will be increased by 1 with whatever the answer is. You divide with it. The answer will be 1 by 2. Minus 1 by 2 plus 1, that's 1 by 2. So you have to divide with that number, and you have to divide whatever is the coefficient of the x here. That's why this 3 is here. Minus 4x, its integration will be 4x squared divided by 2. Minus 2, its integration will be minus 2x and plus c. So you will have this cutting 8 into 3x plus 1 raised to power 1 by 2 minus 2 into x squared minus 2x plus c. So because the curve passes through this point, so wherever is the x, put 0, and wherever is the y, put 13. So I substituted y and the x in this expression. So I will get 8 into 1 minus 0 plus c. So c will be equals to 13 minus 8. So the value of the c will be 5. Now I know the value of the c. So the equation of the curve, this is the equation of the curve. In the place of c, I will put 5. So y is equals to 8 under root 3x plus 1 minus 2x squared minus 2x plus 5. So this is the equation of the curve. So let me show you the answer, sir. We are working on the exercise 9C, and we have done the question number 5, and this question number 5, A part and the B part. A part says that that point will be the maximum point, and the B part, the equation of the curve is given, and here are the answers. Our answers are right. So this is question number 5. This is how you will do this question. This is exercise 9C. This is our third episode on this exercise. My name is Ferhan Mazher, and we are trying to solve the coursebook of the Pure Maths 1 and provide help to those students who do not have access to tutors, and to those students whose their mathematical skills are basically weak. So they need point to point on every step, they need guidance. So this video will be helpful for those students. So now we will do the question number 6, and let me show you the question number 6. Here we go. The question number 6 is a problem solving question. Here we have a curve is such that dy by dx equals to 4 and divided by under root 2x plus k, where k is a constant. The point p 3 comma 2 lies on the curve, and the normal to the curve at p is x plus 4y equals to 11. Find the equation of that curve. So this is exercise 9c. It's last question, question number 6. So let me show you how this is done. I have already done this. Okay. So the equation of the normal at the point P, which is 3 comma 2, the equation of the normal is x plus 4y equals to 11. This is the dy by dx expression given, 4 by under root 2x plus k. Because the equation of the normal is given, I can find the gradient of the normal from the given equation. So 4y will be equals to minus x plus 11, y will be equals to minus x by 4 plus 11 by 4. So the gradient of the normal is minus 1 by 4. So the gradient of the tangent will be, because the tangent and the normal, they are perpendicular to each other. So if the gradient of the normal is minus 1 by 4, the gradient of the tangent will be reciprocal of this and sign change. So that will be 4. So at dy by dx, if x is equals to 3, this will give you the gradient of the tangent, so that should be 4. So 4 under root 2 into 3 plus k, so 4 under root 6 plus k equals to 4. So 6, 4 and 4 cancel, you get 1 here. So cross multiply, under root 6 plus k is equals to 1, so take square on both the sides, so you will have 6 plus k equals to 1. So k will be equals to 1 minus 6, so k will be equals to minus 5. So dy by dx equals to 4 divided by the 2x minus 5. Now I want to find out the equation of that, curve. So I will integrate both the sides, dy by dx into 4. Bring this upstairs, so 2x minus 5 raised to power minus 1 by 2. So when you integrate both the sides, you get y here, so 4. And this power will be increased by 1. With whatever is the answer, I will divide it with the minus 1 by 2 plus 1, that's 1 by 2, so divide with it. And the coefficient of the x, you divide with it also. So plus c, so y is equals to 4 into 2x, this 2 cancels, 2x minus 5 raised to power 1 by 2 plus c. So because this point P lies on this curve, so in the place of the x, I will put 3, and in place of the y, I will put 2 to find the value of the c. So 2 is equals to 4 bracket 2 into 3 minus 5 bracket close raised to power 1 by 2 plus c. So that 2 equals to 4. So this is 6 minus 5. That's 1. 1 raised to power anything. 1 raised to power anything is, excuse me, this is not 3. This is 1. So 1 raised to power anything is 1. So 2 minus 4 is minus 2. So c value is minus 2. So once you know the value of the c, the equation of the curve, put the c value here, minus 2. So this raised power 1 by 2 means square root. So 4 square root of 2x minus 5 minus 2. So this is how you will do the question number 6. So by this question, we have completed this exercise 9c, my dear students. We have done 3 episodes on the exercise 9c, and we have completed this exercise. I hope that this video will be helpful to you. If you think that this video is helpful, and it can be helpful to other students who need the help in their AS Maths, please share the link of this video with them, and like this video, subscribe my channel, share the link of this video on other social media platforms. You see, when you like my video, when you share the link of my video, it's an appreciation for my work, and it's an appreciation and support to my work. Your appreciation, your support, they both are very, very important for me and my work. So thank you very much, everyone. Have a good night. God bless you all.